So welcome everyone to this webinar, which continues on from our previous webinars as we walk through Openshift and how to make it business ready for you and your business. In this particular webinar, we're going to be looking at disaster recovery. And it sounds a very ominous statement, but like in life, the way I look at this is that it's not failure that you or your business should focus on, but it's how you recover from it. So look, whether you're watching live with us today or on demand, either way, we appreciate you giving up part of your day to join us. For those who have joined live today, there's a coffee on us. Please avail of that Starbucks voucher. It can be a tea, of course, as well. No problem at all. So yeah, I've got my coffee here next to me as well. So let's get cracking and let us delve into disaster recovery. So to kick things off, my name is Mike O'Boyle. I look after the EMEA region for Crossvale, and joining me today is our principal architect, Brett Kugler. So we'll be coming in a moment to you, Brett. So before we come on to the agenda itself here that you can look at, let's just do a little bit of housekeeping. You've all joined, and again, thank you very much for doing so. You've joined on mute, but there is a Q&A icon at the bottom of the screen. Please ask questions throughout the webinar. It doesn't matter when you do so. And if you want, you can ask them privately, so we can come back to you later on after the webinar, or you can ask them publicly, and we will take the questions here live, and we'll come back toward the end of the event, and we can take some of those questions. And that's really, I think, one of the most important parts, is because we really want your thoughts about this subject, and the whole subject really about Openshift and the DevOps culture change that we're all living today as we go through. So this meeting is being recorded. You can see that little icon on the top of the screen. But the on-demand that will come from this will be made available within 24 hours of this webinar. And for those who have joined this webinar, an email will be sent out. It'll come from me, so please don't put it in the trash. And please share it with your fellow colleagues in business as well, because they can also not always have had the chance maybe to come and look at this, but I think you'll find that this is really quite a key part to your journey. So as you can see from the agenda, we won't go past 50 minutes. And obviously the sooner I shut up and hand to Brett, the sooner that we'll hit those 50 minutes. But the goal of today's webinar is it's not just to say and talk about disaster recovery and, you know, saying, look, this is essential, it's essential as part of your business strategy. But the most important thing is that it itself is unique. It's unique to your business because your business is unique. And only by us or you understanding your objectives that you're trying to achieve in your business, only then can you decide on the model. So the big takeaway today is there is no one size fits all. And I hope that really gleans out over the next sort of 40, 50 minutes. Now, if you'd like to learn about the fundamentals of Openshift, then please, firstly, visit our website at crossvale.com. You can access our other on-demand webinars, but also I'll be sending, just over this period of a few days, I'll be sending some emails out, and in there will be some really cool links to A, brush up on your fundamentals, or B, really get deeper into this subject and other subjects around Openshift. But we have some great webinars, both past and coming up as well. So please go onto our website and you can learn more about that. So that's ultimately what we'll be doing in our agenda. So very quickly, who is Crossvale? Of course, if you go to our website, you're going to learn an awful lot more about Crossvale than I'll cover in the next 2 minutes, because today isn't about who is Crossvale. It's really focusing on this particular webinar. But in summary, we are covering everything at the enterprise applications and platforms from day 0 through to day 2. What's day 0? Well, that's your build and enablement of those products and solutions that you purchased into. Then day 1 is more about how do you develop those solutions. And then finally, you arrive at that concept of day 2, which is operationalizing and the ultimate maintenance of those that has been put in, both your infrastructure and also the applications that are constantly feeding through that CI/CD. How is that being maintained on a regular basis? So that's really who Crossvale is. And I say, please, crossvale.com to learn an awful lot more. Or of course, talk to me, talk to any one of the sales teams throughout US and EMEA, and we love to come and talk more about what we can do for your business. So what I want to do is get off the sales speech. I will come back to you later on, I'm afraid. So do stick around for that. But what I really want to do now is hand over to Brett, who really will take you through that nice overview and then deep dive into all of the different options around disaster recovery. So Brett, please take it away, would you?
Thanks, Mike. Really appreciate it. And welcome to everyone. Thank you for joining. Hopefully this is valuable to you. We would start with kind of discussing what is DR and why should you consider it, and this is something I think everybody faces in IT. There's lots of different systems and lots of different ways that those systems interact with your environment, and different ways that you have to adjust to them in case of failure. Some of the things that you have to consider with your DR strategy is simply, what does it cost to implement, both in time, in resources, infrastructure, and in skill sets. How quickly can you recover? What is the impact of a particular system being unavailable for a certain amount of time? All of those things kind of guide you towards what is your DR solution going to be. And obviously whatever you choose has to be tested. There's no point in doing something, putting some plan in place without actually exercising it to make sure that it's viable. So those are kind of your considerations from a business objective, right? And this is really critical once we start talking about production workloads and the impact that issues can have on you. Now hang on. Okay, we're all good here. All right, so there's a couple of strategies that kind of can be grouped together, and we're going to go through a lot of these, and we've actually broken them down into a number of tiers. But for Openshift specifically, we start with your architecture and what your environment looks like. So there's a couple of options for running Openshift in the wild, so to speak. A multi-cluster strategy involves obviously having more than one cluster running your workloads. These tend to be very expensive. We'll talk about that in a little bit more detail here. Split clusters, where you're kind of moving your command and control structures across data centers. Again, a very nice strategy, but does come with some very specific planning requirements. And then the kind of single cluster strategy, how do you make sure that it's redundant or recoverable? And again, we'll go more into depth into all of these. So let's talk about some failure types for Openshift. It doesn't have to be an all or nothing kind of failure, right? The idea behind DR, really, I mean, disaster recovery, kind of speaks to this idea that there's been a catastrophic loss, right? But the truth of it, other things can go wrong in your environment that are just as critical, but maybe not a total loss. So things like losing nodes in your cluster, whether they're master nodes or worker infra nodes, losing access to your storage backend, failure of systems, servers, those types of things. We'll get into some examples later on of specifically around NetCD and what happens if that should go bad. That supports the kind of the operational state of Openshift underneath the hood. And then obviously we'll talk about full site failures and how to recover from those as well. So as I mentioned, we've kind of broken down the different options into a number of tiers. And one thing to remember here is that an approach to DR doesn't necessarily have to fall into one of these tiers. It can be blended. And as a matter of fact, what you'll find, I think, by the time we get to the end of this discussion, having a blended strategy actually is the preferred method. And we'll get into reasons why in a little bit. But right off, let's talk about the gold standard of DR, right? And this is essentially these first couple of tiers here where you don't really have a DR problem because you always carry multiple replicas of your clusters. Now, the biggest issue with this is it's very expensive, right? And infrastructure costs for sure. Having replicas of your cluster are, it can be wasteful, especially if you don't have a ton of workload or anything like that. If your applications aren't designed to be able to work in an active environment, that might be another consideration. And then for storage, for your statefulness, that's another thing in an active world where your applications have to sync back to a common data store. So that's kind of the big daddy of preventing issues in your environment from a total catastrophic event kind of position. The second tier around active passive, similar idea, similar kind of spend on the infrastructure side, except now you can turn off that hardware that's kind of backing you up. Another common approach here is to have maybe like a production and a non-production cluster, and then make sure that your non-production cluster has enough free capacity to run some production workloads if required, if something should happen to your production cluster. This is a kind of a mid-tier option, I would say. It does require a little bit more management in the sense that, excuse me, in the sense that especially if you're going to turn that cluster off, it needs maintenance, it needs care and feeding when a new version of the cluster gets deployed or a new version of your application. You want to make sure that you spin up that passive cluster, get it in the current state, and then you can shut it back down. Again, this also requires a linkage to some storage, some persistent storage model that allows you to replicate across clusters. Finally, we have the stretch architecture of an Openshift cluster. Now, this means that you are using a single Openshift cluster. However, you're spreading it across data centers. And this is a good solution for kind of lowering the infrastructure costs, and it doesn't really require any extra considerations except for two things. One, you have to have your data centers within 10 milliseconds of each other. That's the NetCD synchronization maximum. So that's a consideration. Lots of clients can't have that particular luxury. The other thing that you have to consider with a stretch cluster is that you need to make sure your services in the cluster are spread out evenly, or at least in such a fashion that you can retain functionality should you lose one or the other data center. So that's a good place to use things like OpenShift affinity and anti-affinity rules. So and then the taints and tolerations on the server side. So those are kind of the architectural and infrastructure solutions to disaster recovery. Those are your options. Now, if this doesn't really fit in your wheelhouse, then we can talk about kind of your traditional IT DR plans, right? And this mostly revolves around backup and restore, right? So uh, when we talk about backup and restore, we clearly have to focus on two different things. One is we have to focus on the state of the cluster, and then we have to deal with your persistent storage. So these are kind of the operational elements that are covered by Red Hat efficiently. Right? So this is how you manage an OpenShift cluster from the operational level within OpenShift itself. And we'll actually take a couple of examples and walk through this here in just a minute. But essentially, the idea here is you have to back up your etcd in case it gets corrupted or in case you need to recover your masters or anything like that. So we'll show you that process. The other failure scenario is maybe losing nodes and how to add nodes back into the cluster. The nice thing there in both those cases is that OpenShift 4 has made that process much simpler and much more reliable. So those are both, very viable options. However, it doesn't necessarily reach to, a full loss of cluster. So that's kind of your mix. So operationally, as long as you can keep your cluster limping along or moving forward, then you can recover with these particular solutions. So let's take a look at what NetCD Restore looks like. And now we've started this with actually already having done a backup of our etcd, so that already exists. And now the interesting thing here is that, like I mentioned, OpenShift 4 has made this process easier. So there's a bunch of scripts that are available to run to back up and restore your etcd. And we'll kind of walk through that process. And what you'll see is easy is not necessarily simple. I don't know if that's the best way to say that, but there's still a lot of steps. There's still a lot of work on the CLI. There's still a lot of room for error. However, this is kind of the best of breed right now from an etcd restore process perspective. The other thing I want to make you aware of is, depending on what version of OpenShift 4 you're using, this process has actually changed a little bit. So we're running on a 4.5 cluster. So the process, there's a fewer number of scripts that do more. In earlier versions of OpenShift 4, there were more scripts that did less. You kind of had to go through a number of stages. So just keep that in mind if you don't see the exact thing that we're doing here on your cluster, that it could have changed. Again, this is an evolving product, so there's no doubt that things will continue to change. So as we kind of step through this, and hopefully you can kind of see what's the screen here and what's going on. The first thing we're doing is we're making sure that, well, we're doing the wrong thing, right? We're going to actually blow away etcd on our cluster. And essentially what we're showing here now is that all of the etcd elements that are part of the cluster on the physical storage medium is actually removed. Now, this required us to go into the CoreOS masters themselves, place that you're not supposed to be. So be very careful if you log into your CoreOS boxes. And we're just demonstrating here that, for example, all the manifests are gone, the etcd pods are no longer running, etc. So we have essentially completely blown away the etcd environment in this OpenShift cluster. And that's bad, obviously, right? This is the state that we're trying to recover from. So now we're going to go ahead and just run the restore scripts. Now, again, as I pointed out, this would be a pretty boring little demonstration if all we did was run a script that was part of the Red Hat solution, right? So um, essentially that's what we're going to do, but we're going to tweak a little bit, and I'll kind of point out um, where that comes into play so that you can kind of see what's going on. But here you see we have this cluster restore script. This is provided by Red Hat. All you do is you point it to wherever your backups are, and then it's going to go off and do its thing. Now, we're abbreviating this a little bit just for the sake of runtime, but you can see here that it's gone through and done a lot of work to stop the environment and then redeploy. And of course, then we're going to actually restart the kubelet service on the system itself to kind of reintroduce those. And then if we look at the the cryo pod status, we'll see that NetCD is running again, right? So again, we abbreviated this. This process really takes about 15 minutes. You can see that OC is now responsive, and we have our NetCD pods are coming up in the cluster. Now here comes kind of the unique part of the kind of demonstration here. It's not enough to just recover your etcd cluster. You have to go in and you have to make sure that you're patching the revision level. So you go through here, you prompt it to, you prompt Openshift to go ahead and refine and rerun its etcd deployment to upgrade its revision level. And you'll see we can kind of check its status as we go along, and you'll get some information about where you are in the process. And this is kind of just waiting it out kind of a solution. So the key here again is in order to fully recover your etcd cluster, you've got to make sure that your revision levels are accurate. So you've gotten everything back up to date, and the whole cluster is back in sync, right? It's you have to wait until your masters have realigned themselves and are back in the same state. You'll see that here now. We've hit all of our revision levels, and Openshift says now that we're fully patched. So essentially, this is where we want to end up. You can continue to push the revisions and make sure that you end up again in that quiescent state, and ultimately that is an etcd recovery, right? So make sure that you're following your backup procedures, you're using those scripts provided by Red Hat, and then you're storing those backups somewhere safe, possibly multiple locations, and then you can freely go through the recovery process. And any time that your etcd cluster seems to be in a negative state, whether it's corrupted or not. Now, the thing to remember here is, as with any backup strategy, you can only recover as much or up to the point of your latest backup. So either you do this fairly frequently, or you're going to have some level of loss within the environment. So you kind of have to balance what is acceptable in terms of risk for your company. All right. One more example here we're going to step through, and this is going to take a look at how we replace nodes in Openshift 4. And this is a great demonstration because it uses the new machine API to kind of manage the cluster for us. And this allows us to actually very quickly recreate masters. So what we're going to do here is we're going to actually fail the masters, 2 of the masters out of the 3 in our cluster, and then we're going to actually add 2 new masters in to kind of replace those. So here you'll see we have a kind of a standard demo cluster, 3 masters, 3 workers, and what we're going to do is we're going to copy the state of one of our master nodes into a YAML file. And essentially what this will allow us to do later on is recreate those masters by just tweaking that YAML a little bit. So we're going to set this up to start. We're kind of get prepped for this. So again, this is not something that you want to be doing in the heat of the moment, so to speak, when you're having a problem. So make sure that you're taking snapshots of your configurations of your machines so that you can recover these when you need to. So all we're really doing here is, again, changing the name of the master node in these YAML files. And that simply will let us then recreate them later on. Now you'll see our masters are 0, 1, and 2. We're going to come in here and we're going to make our new masters, masters 3 and masters 4, right? We're going to fail 2 of them. So we're going to make that edit in both of our files. And then, so if we look here, we're on on a master node, and now we're going to do the bad thing again, and we're going to actually log into our core OS underneath the hood, right? I'm sorry, we do that in a little bit. First, we're going to go into our NetCD pods, and we're going to actually blow away the. Well, hang on. First, let's demonstrate that this is what our NetCD member list looks like. So these are the 3 masters. Each master has a NetCD table that has this list in it. So what we do is now we're going to go ahead and delete our 2 master nodes. So again, this is a great exercise to go through. Make sure that you're doing it in a cluster where you can afford to lose some productivity on, right? Don't do this at home unless you're well prepared. So we've deleted our 2 hosts, and you'll see pretty quickly that as things start to shut down here, our cluster starts to become a little bit more unresponsive. So now an interesting thing, if we look at the host, the master host that's left, the NetCD table doesn't update itself, right? It doesn't know those masters necessarily were gone. So it's still got them in there. So the first thing that we have to do is clean those out. So we've got to clean up that member list to make sure that those previous systems are completely gone. Now, if you can recover a master node, a pre-existing master node, then you don't have to go through this step. You will actually be able to just bring that right back up, and you'll see that the cluster is actually able to reintroduce that master into the cluster, and it will pick up right where it left off. So, however, now that we're kind of removing these from our member list and all of that, we'll see kind of how this progresses. Oh, and I just went past this for some reason. All right, so let's skip forward here. Let's remove our members. Give this just a second to catch up. All right, so we're taking those out and cleaning up our member table. So we haven't even started the recovery process yet, right? We're still working on destroying our cluster. And this is, again, a very good exercise for you guys to go through just to kind of get more comfortable with breaking things, because that's how you gain a lot of confidence in how to recover and how this all works and all of that. So I would definitely encourage you, have a lab cluster, beat on it, break it, and then try to fix it, right? These are These are all very good standard practices to kind of have under your tool belt. You'll see here that our cluster is now in a very wonky state. It's becoming unresponsive, and we really don't have much left to do here to kind of drive the nail in its coffin, so to speak. So all we do now is we're going to turn around and we're going to apply those YAML files that that we created previously that will tell the machine API to create our nodes again, right? So here you say we do an OC apply against that YAML, master 3 is being created. OC apply against the other YAML, master 4 is being created. If we look, we have 3 and 4 being provisioned. And what you'll find here is, again, very nice feature in Openshift 4, the way that it works internally. It brings the masters up. It starts running the etcd pods. The etcds automatically reach out. They find each other, and those get added into the etcd member list. This video has been abbreviated. This takes probably about, well, the entire process took about 45 minutes. The recovery step itself is probably about 15 minutes or so. But what you'll see is that all the etcd pods come back up. And then if we look at the member list, you'll see that those masters have gotten themselves added into the table without any kind of interference from us. So again, this is a very nice recovery step, or even for scale out, this works. So if you had to add more master nodes to your environment, etc., the machine API really allows you to leverage some of that additional value that Red Hat has built into the clusters to allow you to operationalize a little bit simpler. All right. Sorry. So let's talk about the last couple of options here. And just because they're kind of here at the end doesn't mean that they're inherently lesser. It just means that there are a different approach to DR. Now, I will say that the final option here is probably the least one I would recommend, and that's kind of rebuilding everything by hand. Frankly, it's possible, and if you've worked with Openshift 4 lately, you know that really as long as your environment is set up properly, it's not that difficult to redeploy a Openshift 4 cluster. But everything else that has to come on top of it is something that you have to figure out how to recover. So that's really what our tier 6 here is about. And it's actually an approach that I really like. It kind of takes the concept of Kubernetes and this cattle versus pets mentality, and how we treat containers. A failing container just gets thrown away, and you spin up a new one. It takes that mentality and it kind of brings it to the infrastructure as well for your cluster. And we've spent quite a bit of time working on automated rebuilds, what I call the recreate scenario. And this is kind of soup to nuts. So not only are we talking about redeploying your OpenShift cluster in kind of an automated fashion, so push button kind of solution, but also your CI/CD pipelines and then your applications after that. And really, this is something that is kind of really adopting that Git Ops model, which we'll talk to you about in a second. Now, you do have to have some tooling that will allow you to run that automation, to get all of that deployed and all of that. Now, from a time perspective, again, your impact might be a little higher, but the real important driver here is you can do this at any time. And so I've actually seen clients implement this to be able to spin up clusters kind of on a whim, right? I mentioned earlier, if you want a lab cluster, well, you don't necessarily always have to take the impact hit of that lab cluster. You can just spin that up and when you're done with it, tear it down, right? And having this automation built in really allows you to kind of reach that level, right? And it's important to note that I think, again, a blended solution is probably where you'll end up. So we have a lot of clients where we build stretch clusters, and then we give them this automated rebuild so that you can kind of balance, a little bit more reliability on the infrastructure side with all of this automated redeploy that you get on top of it. So that there's a lot of value in kind of considering that approach. Now, I did mention Git Ops. I want to talk about it briefly. If you're not familiar, there's lots of good resources out there on Git Ops, but this is kind of a branch, if you will, of the whole DevOps movement, right? And essentially, it's about infrastructure as code and being declarative in what you want. So rather than going through a step-by-step process to rebuild your infrastructure, you ask a system or you tell a system, hey, give me this, and it goes out and deploys it for you. Now, this requires a certain level of skill set, right? There's nothing here that does this out of the box, so to speak, for you. In your environments, will also determine what process you're going to use if you're on-prem with VMware or in the public cloud with Azure or AWS or what have you. But you get back to a good known state every time, and that's maybe the most important part of this conversation, right? Everything's going to deploy the same way. You're always going to start with a level playing field, so you can always kind of catch up, right, to where you were. And you can work in notifications, you can work in approvals. All of that can get built into the pipeline as well, so everybody can stay informed and understands what's going on during the recovery process. All right, so let's talk a little bit about what options you have with your vendors. So if this sounds like a lot of work and kind of considering your DR strategies and oh boy, this, how do I deal with this? Maybe I'll just go with a dedicated solution or a managed offering. And the thing to remember there is that the services that are available really only guarantee the control plane for the most part. You still are responsible for your applications and keeping them persistent and making sure that they are recoverable. So it lessens the impact of a situation because it shifts the responsibility for the infrastructure onto the provider, but it doesn't necessarily absolve you of anything because your applications will still be impacted and you still have to have a recovery plan. And again, if you're running on-prem, then those solutions are really not solutions at all for you. Now, there are some tooling that allow you to kind of give you a little edge up, especially when it comes around to persistent storage and how to recover from your environments. And essentially, sometimes this requires vendor-specific products. Sometimes these are still very immature products. Again, everybody's chasing Kubernetes as it continues to advance, and so this is still a very, I would say, immature part of or aspect of the tooling around Kubernetes is this recovery model. So tools like Valero and kubedr are good. They do as advertised, but they're just one small part of the puzzle. And then when we talk about storage, storage is very reliant on whatever your backend provider is. So every vendor kind of has their own replication strategies, their own recovery strategies, backup, and so forth. So it really depends on what's going on behind the scenes. So an interesting perspective to this, and this is something that we've talked with a lot of clients about, is when you're moving to the cloud, when you're moving into Openshift, take a look at your applications. It may be a good time to refactor them and to reconsider your persistent storage needs, right? If you've got an application that relies heavily on file-based storage, where you're constantly writing state to disk, you may want to refactor that. You may want to use a database to store that information and make your applications truly stateless from a disk perspective, and that will help you kind of in these situations, in these DR situations, recover faster, because now you don't have to necessarily worry about your underlying storage because your applications are no longer utilizing it. So that's an interesting kind of new way of thinking about your application design that will really help you moving forward in this new containerized. And with that, Mike, I'm going to turn it back over to you.
Thank you very much, Brett. That was really, really good. That whole concept now is getting very interesting, because what you've done, Brett, is you're starting to show us that we look at the tiers, and we look at tiers of active, and they're very high cost, and we tend to think of money as being a focus. And you've walked us through towards Git Ops. But I think what's been very clear to me as well, and I hope to the people listening today, is it's not a well, this is a cost decision, and the scale just comes down. And if you don't have much money, you do Git Ops, and if you've got bucket loads of money, you do active, right? That's something that seems to be coming across, Brad. Would that be right? A fair takeaway for a second?
Yeah, absolutely. Again, you have to decide where on the curves you want to meet, right? You've got to make sure that you have the right skill sets, the right budget, right infrastructure. All of this will come together to kind of drive the decision for you.
Yeah, exactly. And I think so for everyone, let us just take this a little step further, because what can Crossvale do? Well, apart from the fact that Brett is extremely knowledgeable on Openshift and all the things that surround it, he also manages a global team of consultants, and obviously their job all over the world is to not only deliver Openshift and walk it through to a state that works for your business, but inside that, looking at this disaster recovery area. So you get it out, you unpack it, you deploy it, right, Brett? And then you start looking at how it's working for your business. And that's where we start to look at not DR, disaster recovery, but more this ERM. And sorry for all the acronyms flying around a million miles an hour, but this sort of efficient risk. Where do you make that crossover? And you can see the chart there on the right hand side that really it is a cost and a time involvement, and with that you're looking really at a risk factor, and there's a crossover point, and that's where we really at Crossvale map out what it is you really require, and from that come with a summation of these different types of DRs to create one overall strategy that works for the business, right, Brett? That is what your team are doing every day. And I know when I'm talking to customers and you guys are involved, it's always, we go in and we present what you've just been talking about, but it's multifaceted. And again, it comes back to that original point I made, no one size fits all. So taking this a bit further, our business is all around looking at where you want to be. We see this the to be state where you need to be in the future. Where is that? Where are you now? Where do you want to be? That's DevOps, right? We all get that. And that's what we're looking at. And that's where we get this crossover point happening to build that efficiency in risk versus cost. So again, we can build, we test, we validate, and it's most importantly, we then can also maintain. So what you end up with as a business is either for yourself or for us doing it for you is a complete DR solution, not just looking at which tier do I choose, that's going to be my strategy going forward. So Crossvale, when we look at Crossvale, Openshift, and the sort of the DR services that we build into it, what you look at is some of the points that you see across the screen now. We've touched on some of these. We have an ERM, an efficient risk model, which really works for you, for your business, where we come in, Brett's team come in and talk about what is the right fit for you. As a result, we can reduce your operational overhead, which is what we do anyway with our managed services around operationalizing Openshift in your business, and getting that right size DR for your applications. It's all great and good to look at your infrastructure, but one must look at the applications that are sitting upon those and say, okay, we have monolith, or we're looking more at a cloud native where we're looking at Node.js and things like this. And are we now looking at microservices? Are we looking now at service mesh that fits within there? There's a whole load that we need to consider connected to DR. And not just service mesh itself, but the DR connected around the service mesh, looking at the latencies and things like this are going on. And if you work your way all across there, it's also very important to note at Crossvale, we as a CCSP can also provide very flexible ways to consume those solutions of Openshift and things connected to it. So as your consumption rises and beefs up, into a month, your demand increases, so you use more of the Openshift. And as it lessens, or in the case of DR, as you don't need the DR, and let's say in an active passive situation, then of course your consumption lowers as well. So really what you get is this real delivery of an application ecosystem working for you. And that's really what we can bring to the party for you. Going the right way through the slides is an awfully big help as well. So that brings us, I know we've talked about this before in other ones, and I'm not going to go into it today at all, but do recall the fact that we offer therefore the complete managed services around Openshift and operationalizing that for your business. And what we'll do for you today is we will offer a free disaster assessment of your current cluster. So get in touch with us, go to the landing page that you'll be sent to in a moment. After this, again, I remind you'll get an email from me. There's a link there. You'll land on a landing page to share this link for the webinar, but also you can apply for this free disaster assessment. It will take very little of your time. It's all around what we do. We have automated scripting from YAML, etc., through Ansible that we can drive into your infrastructure to glean from it the information, and then we can come back with a report to really help you learn where you can improve yourself, completely yourself, take it on yourself, or where we can come and help you do that. And that's really all around the managed services as well. So we've just a few minutes. We're coming very close up to the 50-minute marker. So Brett, you did a very good job of keeping it on time. And as usual, I'm pushing it along. But let me just take at least two questions here. I apologize at the beginning. I didn't have Q&A switched on. I turned it on while Brett was talking there. So it's live now. And I'll certainly take these questions because I think it really does feed back to what you were talking about. Let me load you with this question. Do you have a strategy that works better for cloud compared to on-prem? And does hybrid present any further challenges to that?
Well, I think we go back to the original look at your infrastructure and your architecture. And I think, again, your recovery process is going to be different whether you're in the cloud, whether you're on-prem, or whether you're kind of doing a little bit of both. There's a lot of tooling in the public cloud that will allow you to kind of adopt that Git Ops model maybe a little quicker because they're all built around that themselves. And so if you can, if you have the skill sets to kind of adopt those practices, that's kind of a good option for kind of driving that. And if you're on-prem, maybe you maybe need a little bit more VMware skill set, or if you're on bare metal, there's a whole nother factor of things to consider there. But I think ultimately the answer really comes down more to the architecture and the design of your clusters, rather than necessarily where you're running it. The automation that we would recommend certainly can span any environment, similar to the way Openshift itself can run anywhere. So again, it's more about adopting, I think, the right strategy for your deployment needs rather than you know, picking an environment based on the you know, the ease of DR recovery. That's redundant, but you get what I'm saying.
Yeah, absolutely. Actually, you raised a great point just as you were opening up there. And you said, if you get the architecture build right from day zero, that really, it's not about that it lessens the fact that you can get a DR. You know, a machine can go straight through your cable outside the building and suddenly you've got a DR. You're not going to be able to plan for that. But if you can get your architecture right, that's already what sort of adds the value and the building blocks. It's like the foundation blocks, isn't it? I know we spoke about this in a previous webinar. It nearly answers the second question. Someone asked, what is the most common DR that you personally, Brett, have come across, maybe in Crossvale or prior life?
Well, so I think, you know, we see a lot of the traditional, when we talk about standard IT environments, we see, you know, backups and recoveries being something that people are very comfortable with from a process perspective. Now, every little thing that you deal with has its own little quirks and how to recover. So, you know, they're very much a series of one-offs in processes. And then you have things like appliances that you find in traditional IT shops. And then, you know, multi-data center kind of environments, you make sure you have like for like, so you're replicating your infrastructure. That's very traditional IT. When it comes to OpenShift, I think many people are still struggling a little bit with what that looks like in this environment, because again, we're not just talking about infrastructure, we're talking about everything that rides on top of your clusters as well. And how do you recover those, and what, you know, how do you manage that statefulness? So it's a bigger balloon of a question. And I really think that people are still really struggling with what fits for them, and do they have the right skills to manage things the way that they really like to. So I think the answer to your question, Mike, is it's still evolving. Folks are still maturing. We're trying to help our clients understand these needs, understand their options, and then adopt best practices around automation and driving that automated recovery, regardless of their spend on, you know, infrastructure and what they're capable of handling from a multi-cluster perspective.
That's a good one. It's an evolution, not a revolution, right? It's something we've talked about before. Firstly, Brett, to you, thank you for your really thoughtful insights throughout today's webinar, but really mostly to everyone else. I truly appreciate the time you're giving up, whether you're on the on-demand or whether you're live today. Enjoy your coffee if you're live. Please do make avail of that. There is a quick survey afterwards. Please, please, please. Thanks for the questions, by the way, but thank you more for ahead of time filling out that survey. Again, when you go on the landing page afterwards, you know, contact us about the disaster assessment. It's really, really good assessment, and it costs you nothing apart from a very small amount of your time. So I thank you all. Have a great day and all look after yourselves. Thanks very much, and we'll see you again soon. Bye-bye.
Thank you.